Now let's look at another concept, address banding. Basically, addresses represented in different ways at a different stage of a program's life. For example, when the program is still a source code, the source code address is usually symbolic. So for the symbolic code, you can deem it as when we learn the C programming, the symbolic code like a pointer variable. So through this address, you can get some data or get some functions. So when the source code get compiled, the compiled code addresses will bind to relocatable addresses. The relocatable addresses means that the program can be put anywhere of the main memory as long as knowing the beginning relative address of the program and the size of it. For example, we have 14 bytes of a module started from a relative address x. As long as we know the beginning address of this module on the main memory, so we can locate the entire module. So for this kind of address is called a relocatable address. When the compiled code is linked or loaded on the main memory, the linker or loader will bind the relocatable address to absolute addresses. In other words, we call it physical addresses. For example, let's still use the previous example. When the loader or the linker knows the relocatable addresses of the module, it will add the relocatable address of each instruction with the relocatable register together to get the absolute address on the main memory. For this whole process, each binding maps one address space to another. Then let's see how we combine the instructions and the data to main memory. There are three types of address binding of instructions and the data to memory. The first one is a compile time binding. For this one, the compiler is in charge of the address binding task. So before the process has been loaded onto the main memory, the absolute addresses of the process are already known. However, if the absolute addresses are already occupied by other processes, the conflict will be happened. This process must be recompiled to change the absolute memory location. So we also call it static binding. The second type is called load time binding. The loader is responsible for this type. So before the process gets loaded onto the main memory, the absolute address of the process are not known. The loader will add the relocatable addresses with the relocated register together to get the physical addresses. The last type is execution time binding. Before the process executes on the CPU, the absolute addresses of the process are not decided. So CPU is responsible for the address binding task. The binding delayed until runtime so that the process can be moved during its execution from one memory segment to another. So commonly in nowadays operating system, this task is implemented by hardware in order to improve the efficiency. For example, you may still remember the base and the limit register example. So when the CPU passes a relative address to the special hardware, the hardware will dynamically translate the relative address to absolute address and check it.